Alright, hi, this is Will, and we're going to talk about the setting up the linear actuator and how we get the properly set it up and configure it, and so we can get the serial commands from the PLC into the linear actuator. We had a previous video under serial commands, and that was from the PLC point of view. So now we're kind of taking a look at it because this is in the linear actuator section from the linear actuator point of view and how we're going to set that up. First, I want just to take a little walk around as to what exactly we have. And over here is how we have the PLC platform hooked up. And right now I've got my pink Ethernet cable, and I've got my serial cable, and my serial cable runs over into my stepper amp. And so that's what we use in the system, and that's the normal operation. Now what we're going to do for this is we're going to and I also have, because I've got USB, I've got a USB connector, and then I've got my protocol converter to get to Ethernet. So what you get when you're programming the stepper driver excuse me, is they come up with this cable that you need, and this is a cable that it has I guess a RJ12. It's you know, the old type of phone cable on one end, and this plugs into the stepper driver, and the other end is a DB9 female. So most computers nowadays don't have that. So you're going to need a little adapter, and just like we had an adapter for the Ethernet, we're going to have an adapter for you know, this cable. But this cable comes with it, and while I'm thinking, and while we're talking about it, the serial cable that we normally use in operation, you have to buy that one from Automation Direct. And this cable you have to buy, and if I'm looking at it, I'm not sure I can get close enough to show the part, but it's STP-232 RJ12-CBL-2. And that's a cable you get from Automation Direct, and you need that for the serial commands from the PLC to the stepper drive. And also, and we talked about this in the other videos, but this cable has cable markers on one end. And this marker actually says drive end. You have to make sure that the cable markers are at the drive end and not at the PLC end. If they're at the PLC end, it's not going to work at all, because the PLC to the stepper, it's not a straight through cable. So you're going to get the wrong signal at the wrong spot, or some such problems, but it's not going to work. So the first thing I'm going to do, and I'm going to just stop the video for a second, because I'm going to have to disconnect our system cables, connect up our little programming cables, and then we'll show you what we need to do to program it. It's a really simple type of programming thing, so that's not a problem. So we'll be right back. So we're back, and now we've got the test cable hooked in, so I've got my little adapter right here, and going into my computer, and we'll be good. So now we're totally disconnected from the PLC, at least my PC is, and it's not connected to the stepper drive. And the only thing the platform is doing at this point is supplying 24 volts to the servo. So what we need to do is, let's take a look at the software, which I have hidden under the webcam. And this is the SureStep Pro software, and you can get it from Automation Direct. It's free download also. And okay, so it says error in COM1, it'll try COM2. Actually, neither of them are going to work, but this is a good little reminder here, because the first thing we really need to do is we need to figure out what port is my little adapter device hooked into. That's what we're going to need to know. So I'll go into Device Manager here. Device Manager. And I need to find out where my adapter is hooked into. And so we're hooked into COM3. That's what we're going to need to know. So here's the outlay. It doesn't really expand at all, but you have 4 blocks. So you have a drive block, you have motion and I/O, you have the motor block, and then there's the download. And you know, it's well, it's really easy, but there is one little snafu in the process, and we'll talk about that, and you'll be able to see it since it happens like every single time I try to program these. But you go in here and it says what type of drive, and it comes up by default as an 8100. And we are using the 4850. So we click that, that box is done. If we go into motion and I/O, all we have to do is go in, well, you can either have pulse and direction. We can't do that. We don't have high-speed outputs. Velocity, oscillator, we don't have a high-speed counter or timer if we're going to do that. But what we use is the serial command language. And we go in this. Now, this is all, we can leave all these defaults as is. Now, well, we can leave these defaults as is for the four-step or four-sensor configuration. For the single sensor configuration, what we have to do is we have to know when the motor is actually moving or not moving. So there's this output bits on the PLC, and this larger connector is for the power for the stepper motor, but the one next to it has some signals, and it has the enable signal and the output signal. We use the output signal to tell us when it's on or not on. And I don't have the schematic in front of me, but basically it's a transistor inside the driver amp, and you can either take a look at it, and we send it a voltage and a ground, and we look at that signal, and you can either have it closed when it's moving or open when it's moving. And I'm pretty sure we have this, and I'm not 100% positive, but we'll find out really quick. We say open when it's moving. And we're okay with that. And we can go down to the motor. And now our motor is going to be, we have a size 23 motor. And the two options are the 23055 or a 23079. Now, our motor isn't marked with either of those descriptions, but we've always used the 055 and it works fine. So you should be good. The only other thing, we leave all these defaults as is. The only other thing is this load inertia. We just tweak it a little bit because it'll come up with an error, well, or a warning that says, hey, you haven't adjusted that load inertia. I don't think it matters because all we're doing is we're just transporting a cup down the linear actuator. The linear actuator has more than enough torque to do that. So we're okay. And now the last step is download to drive. And here's where we always run into a problem, and it's not a major problem. You just need to be aware of it because the first time you do it and it doesn't work, you think you're doing something wrong, and I'm pretty much convinced myself that it's the software that's bad. So I'm going to go in, and we're in count 3. Now when I try to download to the device, right here is a progress bar, and it's cyan. If it downloads correctly, it'll just go across the screen and this progress bar in about half a second. Now, I don't think it's going to do that, so let's just try to download to the drive. Oh, it did. So you can see it go zipping across really fast, and that means it's programmed. Now, that was kind of unusual. Usually it doesn't do that. So what you have to do when it doesn't work, it'll just kind of sit there. Sometimes it gives you a message that says you should recycle power. And if it doesn't download really fast, and it'll be just like that when it works. You hit download, it just, you get that right across right away. So what happens is you need to turn off power, and you need to turn it off for a good 10-15 seconds before you recycle power. Try again. It usually works on the second time, or the first time after the recycle of power. So now the last thing that we want to do, we have it configured, or what we say, and also if we look at this configuration now, it tells us we've configured, so now it's giving us feedback that says, okay, you've got the 23055 drive, you've got set up for 20,000 steps per revolution, and now it says everything is going to be set by SCL, the serial command language. So that tells us that we have gotten this feedback that it works, but the thing we really need to do is, in this drive, there is this self-test. And the self-test just operates in a very slow fashion, the actual drive. And, well, let's take a look. It does tell us what it does. It says motors should be turning at half revolution in a quarter second, and it should be going backwards and forwards. So I'm going to take the webcam over, and we're going to take a look. And you know, sure enough, our shaft is just rotating slowly back and forth. So you can see that, and you know, that kind of shows that our system is running. So at this point, we can say, okay, we've configured everything correctly. Our stepper motor's in good shape. Oh, and by the way, let's also, I just want to take one look here in our little view graph. So we kind of programmed it, and then we still have the feedback, and we have the feedback as to whether the motor's operating or not, and it goes to bit 208. And in our, I don't know, designation scheme, 208 means it's input bit 8 on the expansion card number 2. So we have 2 expansion cards and it's bit number 8. So if we look at this, my webcam wants to reach over there, what we have is, you can see it's mostly off and then it blinks on. So when it's blinking on, it's just stopped for a little bit of a time period to reverse directions. So when we did say that we were going to have it open while it's driving, and actually let me see what we did say we were going to set that up for, is we said it was going to be open when motor is moving. So it was open when motor is moving. So now we have good confidence that the stepper is configured right, that it's operational, we know it's working and it's doing what it should. So if we go back and now we have problems when we hook up initially with the PLC, you know, there's 2 things you need to look at. There's a configuration of the serial port on the PLC, and that needs to be configured right. And we had a video under the serial command show how to do that. That's a pretty simple setup too. It's got to be 9600 baud rate, and you know, it's got some other factors that you need to configure correctly. So that's one of the problems you could have, or that your actual commands that you're trying to control the stepper motor with is wrong. But at this point, if you run into a problem operationally from the PLC, you got to be thinking that the problem is inside the PLC. It's either the configuration you use on the serial port, or it's the exact type of commands that you're using. And so that is how you configure the stepper motor driver. What we're going to do in this next video is we're going to show you, you know, actual commands that we use for the 4-sensor design and the single sensor design. Now, it's not in the exact format that we use it in the operational system, and actually what we're going to do is kind of useful for some test purposes. But you can take a look at those commands, see what the format looks like, and you should be good to go. So we'll see you in the part 2 of the linear actuator demo. Thanks.